This is 12.3, and we should fly through this pretty quickly. I think you could probably do it without my help, but I'm going to help you anyways. So here we have the equation u squared equals 36. So we take the square root, and anytime you square root a variable squared, you need a plus or minus. So u equals plus or minus 6. All right. Here we need to solve. In order to solve, I need an equals 0 on the right side. So I will add 5 over. 3u squared plus 16u plus 5 equals 0. I can't pull anything out, so I use the box. This has a leading coefficient, so we stick that in here, and then we stick this in here, multiply those together, and I get 15u squared. And that is a positive number, which means that my signs are either plus plus or minus minus. Are there factors of 15 that add to be 16? Yes. 15u and 1u. Looking at the top row, they share a 3u. If I pull out a 3 and a u, I'm left with u plus 5. And if I remove this u from the first column, I get 3u plus 1. So my factors are u plus 5 equals 0, and 3u plus 1 equals 0. This one's simple, just subtract, and I get u equals 5. Here I need to subtract 1 and divide by 3, so my other root is negative 1/3. So again, hopefully that is review from the last chapter. So I want to do the same thing here, except this quadratic only has 2 terms. There is no constant. So you could figure out a way to factor this using the box, but I'm just going to look for the greatest common factor. So what goes into both terms? 4v. If I yank out a 4v from each of those, then I'm left with v minus 3 equals 0. So this is my first factor. 4v is equal to 0. And my second factor, v minus 3 is equal to 0. Divide by 4, v equals 0. Add 3, v equals 3. Now if you think about that, this graph had no constant, or the constant is 0, which means that the y-intercept is 0, right? So if I had x squared plus 6x plus 7, this tells me where the y-intercept is. And this equation has no constant, so the y-intercept is 0. And if the y-intercept is 0, then one of the roots also has to be 0. And that's always going to be the case. All right. On the left side, I do u plus 4 times u plus 4. And that gives me u squared. This is 4u and this is 4u. So 8u plus 16. And that's equal to 2u squared plus 10u plus 1. I need to move everything to one side. I prefer quadratics that do not start with a negative number. In fact, I haven't taught you how to do that, how to factor quadratics with a negative leading coefficient. So I'm going to move everything this way. Subtract u squared minus 8u minus 16. So we get u squared minus 2u minus 15. And that becomes u minus 5 and u plus 3. So the roots are 5 and negative 3. The area of a rectangle is 45 meters squared, and the length of the rectangle is one more than twice the width. So length and width. The length is one more than twice the width. So the area is 45, and the area is also L times W, which is 1 plus 2W times W. So I get 2W squared plus W, but that is equal to the area of 45. So 2W squared plus W minus 45 equals 0. So 2W squared, negative 45. Multiply those together, and I get negative 90 W squared. Are there factors of negative 90 that add to be 1? So 1 and 90 doesn't work. 2 and 45. 3 and 30. 4 doesn't work. 5 and what would that be? 18. 6 and 15. 7, 8, 9, and 10. There it is. And I need a positive 1. So plus 10W and negative 9W. So I pull out a 2W, and I'm left with W plus 5. And then pull out a W, and I'm left with 2W minus 9. So W plus 5 equals 0, and 2W minus 9 equals 0. So W equals negative 5, and W equals add the 9 and divide by 2, 9 over 2. Well, this one really doesn't make any sense. The width of the rectangle is negative 5. That can't happen. So we're going to throw that one away. Okay. So the width is 4.5, and then we plug the width in here to figure out the length. So 2 times 4.5 is 9, plus 1 is 10. So the length is 10 and the width is 4.5. All right. X squared equals 45. So I square root, and I get x equals plus or minus the square root of 45. Well, 45 is made up of 9 times 5, 3 and 3. So I'm looking for pairs. There's a pair. So I bring it out. X is equal to plus or minus 3 root, and the leftover is a 5. So plus or minus 3 root 5. All right, Keisha cut squares from the corners of a rectangular piece of aluminum. Each square has a side length of 3 centimeters. She then folds the aluminum upwards to make a box with no top. The length of the original piece of aluminum was X centimeters. The width of the original was 1 centimeter less than its length. Figure out the dimensions. Okay, let's go up a little. So over here, the volume is 546. So the volume is going to be length, let's do it this way, length times width times height. Well, the height is 3. So volume equals length times width times height. So the volume is something times 3. So the width would be this right here. So that is x minus 1 minus 3 minus 3. So the width is going to be x minus 7. Okay? And the length is going to be this, which is x minus 3 minus 3. So we get x minus 6. So x minus 6 times x minus 7 is going to be x squared minus 13x plus 42. And then that needs to be tripled. Okay. And then that is equal to 546 cubic centimeters. So 546 equals 3x squared minus 39x plus, that would be 120 plus 6, 126. Move this 546 to the other side. 3x squared minus 39x. All right, 126 minus 546 is a dead calculator. Okay, we'll try it this way. So 126 minus 546, negative 420. I can pull a 3 out of that. So 0 equals x squared minus 13x. What's that going to be? 140. So I need factors of 140 that add to be 13. So 1 and 140, 2 and 70, 3 doesn't work. 4 and 25 plus 10 is 35. 5 and 28. Okay, I'm trying to get a 13. 6, 7, and 20. There it is. So it's x minus 20 times x plus 7. So x equals 20 or 7, or negative 7. But negative 7 doesn't make any sense in this case because we can't have a negative side length, so that goes away. So x is 20, which means that this is 20 minus 1 minus 3 minus 3. So that's going to be 13. And then this length here is 20 minus 6, which is going to be 14. Okay, so the length is 14, the width is O of the original piece. Okay, I lied. That was the dimensions of this. So this length is 20, and this length is 19. Okay, same thing here. You're just going to factor. All right. This time we have no x term. So I could move this over and say 2x squared minus 90 equals 0. And you could figure out a way to factor that. But because there is only a single x in this, I'm going to add this to the other side and get 2x squared equals 90, and then divide it by 2. And I get x squared equals 45. Then take the square root, and I get x equals, and this time it wants a decimal. So I'm just going to type in root 45 in my calculator. So the square root of 45 is 6.7. So this is plus or minus 6.7. All right. Write a quadratic equation whose roots are -5 and 2 and whose leading coefficient is 5. So I know that x equals -5 and x equals 2. Those are the roots. What would the factors be that are associated with those roots? Well, I would add 5 over x plus 5, and I would subtract 2 over x minus 2. And that gives me x squared plus 3x minus 10. Now I did that in my head. So x squared, this is a 5, and this is a -2, which is where I got the 3, and then that's going to be a -10. So that equation hits the x-axis in those two places, but I want an equation whose leading coefficient is a 5. So I want a 5 right there, which means I just times the entire equation by 5. 5x squared plus 3x plus 15x minus 50. Now, what is the difference between this equation and that equation? Well, the original one, this version, hits at -5 and at 2. But so does the new equation. It's just 5 times taller. So the new equation would look something like this. Okay, same here. The zeros are 6 and 1. So x minus 6 is one of the factors, and x minus 1 is the other factor. Hopefully you can multiply these in your head at this point. X squared, that gives me a -1. That gives me a -6 for a total of -7, and then plus 6. All right. Just solve this for x. So we subtract 5. V minus 3 squared equals 20. Take the square root. V minus 3 equals plus or minus square root of 20. And then we add 3. And that is our answer, but we want it in decimal form. So 3 plus the square root of 20 and 3 minus the square root of 20. All right, that's it. What did I say this was? 12.4? 12.4. Get to work.